Okay, we're doing an example from 2.6 and a limit involving infinity. So now before we've been just using numbers here, even right side, left side, etc. But numbers, what do we do with this infinity? How do we approach this? So what we do here is you take the largest value of your exponent in the denominator, not the numerator, the denominator. So in this case, this is x squared. You divide everything by it. As long as you do the same thing to everything, remember, you're okay. So we are dividing everything by x squared over x squared. The idea here is we want to get a 1 here that we can work with in the denominator. We still got the 5 out here. Okay, so now what do we simplify this to? This becomes 1 over x squared minus x squared over 1 plus 6x, and of course this is all to the 5th. Not really that important, but still, might as well keep it with us. We need to be put. Now, let's talk a minute here about what's happening. What happens if you take a really large number into a constant? So let's take this 1 and let's put a number with a ton of zeros here. What happens? We got a really small number. The idea being that as this goes to infinity with a constant here, this will always go to 0. So these all become 0. So what we have is we have negative x squared over 1 to the 5th. So what we have here is negative x to the 10th. But that's infinity. So this really is just going off to negative infinity happily as can be. So this is negative infinity. Let's check the answer here. So that's our answer. So you can see the trick here to solve this is to divide everything by the largest exponent in the denominator, so that then you can cancel out, you can zero out most of these terms, and you can see what the true value of the function is. What is it doing? In this case, it's going merrily off into infinity. In this case, negative infinity, but it could also be positive infinity. But we can't have an infinity in the denominator, so we needed to get this 1 down here, so we had it up in the numerator. Infinity in the denominator is a problem.